Hi friends, this is very important topic. Today we are going to learn in this session Latin square design analysis. Okay, you learned all the theoretical part about the Latin square design, right? So we need to apply that theoretical part in the Excel. So it's easy to do the analysis of your research data. So in this session, we will going to see the Latin square design, which is used for the analysis of your research data. So stay tuned with us throughout our lecture. Otherwise, you won't get anything from this session. So that you can stay tuned with us throughout the session. I will explain everything and what type of formulas we will going to use in this sheet. I will explain that as well, and also you can make your own sheet, or if you want this type of sheet, then definitely you contact me. I will provide this sheet as a paid sheet. Okay, so if you have any query regarding this design, then definitely ask me in the comment box. I will definitely answer your any question regarding this design or regarding any other design which is related to your research, because we develop so many programs in Excel for the analysis. Okay, because it's easy to doing analysis in Excel sheet as compared to the any other software, because if we need to modify anything in this data, then definitely we will going to modify in Excel sheet, because it's a easy one and we will get the result at a real time, so that it's easy to modify as per our need or as per our advisory committee. If they guide you, then definitely you will going to succeed in your thesis. Okay, so we can start our a Latin square analysis design. Okay, so I consider here is a 5 by 5. It means we consider this as a t square, because we consider the treatments over here. In Latin square design, we will square that particular treatment. Means we, if we consider the 5, then definitely we consider the t square. It means 5 square. It's a 25 number of plots in this design. Okay, so you can see here, you can put the character name, whatever character you consider for the analysis in then definitely you can put that character name over here, so that it's easy to understand what character analysis is this. So in treatment, we can consider over here the row and column. You keep in mind, here is the row and column, because if we apply this design on the field, then we can control the fertility in gradient of soil in a two-way. Okay, so here is the row and column. You see, you can consider here the row and column. See here the R1, R2, R3, R4, R5, then C1, C2, C3, C4 and C5. These consider the column and this consider the row. You can see here allocated treatment. So we can allocate the particular treatments having the symbolic number. It means that just a symbol like A, B, C, D, or whatever it may be. You want to give the number for this, you can give that. Okay, so but you can keep one thing in mind when you are going to allocate these things, because you see here in Latin square design, we should have to consider the treatment allocation is very meticulously, because we need only one in a row or in a column. Okay, we don't want to repeat any treatment in the same column or same row. You can see here A, B, C, D, E, and here is A, B, C, D, E. I'm not repeating any character, like I put here the B and I put here the B and I put here the not. I'm not repeating anything. You can see here B, C, D, E, A. I'm not putting anything because A once, D once in a row or in a column. Okay, keep in mind, this is very, very important. Okay, so this is the only number. There is no any type of formula required for this. You can allocate any treatment which is needed to you, but you follow this only, it's a better one. Okay. And why this only 5 by 5? Because we should have to consider here the error degrees of freedom. You see here the 12, because we use the thumb rule or something, is the minimum error degrees freedom should be the 12. If you want the design for 4 by 4, we will provide that as well. 3 by 3 also we will provide that as well. But sometimes they need it. Okay, only if they are considering the error degrees of freedom should be 12, then you should have to follow the 5 to 8. And this is the limit of Latin square design, is just having the 5 treatments to the 8 treatments. Why not more than 8? Because it's unable to manage the field if we consider the more than 8 treatments. Okay. And why not below 5? Because we have constraint about the error degrees of freedom, because if it's less than 12, then there is a no point to do the analysis of that things, and no variation is there, and like that things are there, so that we consider only the 5 to 8 treatments in Latin square design. Okay, so you can see here, as per the data obtained from our research, we put the values over here in the red color. You can see here I put the value for A, so that I can put value for here the A values. Then another A we can see here is A, and this is the A value. You put as per your treatment values in this column and row. You'll get here the column total and column average. For total column, you can sum up all these rows value, then you will get the column total. For next column, you can do the same. Then average, you will know the average is very simple. Just sum up all the observation divided by number of observation. You will get the sum of this observation. You do same things up to column 5. Okay, so next is row total. In row total, we can consider the column value. For the row total, you can consider this is the C1, C2, C3, C4 and C5 values are total. You can see if I select all these values, it will get 44. You can see here, you see mouse here, 44.50, and I consider 5 value, that is count 5, and average is 8.90. You can see here, this is the formula, just some formula, then this is the average formula. Okay, then next is a very important, when you are going to do the treatment total, then it's definitely having something to do the treatment totals, because it's a little bit tedious task, and we developed this in our design to do it automatically. And you can see here, if you consider the treatment A, then you should have to sum up all the treatments of A. You can see here, I'll show you, this is the A, so that I will select this A. Okay, then another A is in per second, this is the A, another one, this is the A. Okay, another one, this is A and A. Okay, 1 2 3 4 5 A's are there. Okay, you can see over here the 5 count and 68.50, and you see here 68.50. This is the treatment total for A, correct? Now I think so it's understandable everything over here, because we are not going to see the theoretical part. This is the very important, so you just consider me, and you can repeat this same procedure for B, C, D, E. Okay, then you need to obtain the treatment average. It's a very simple, you just consider this the treatment total. You have the treatment total, then you need to only make the average of this. Okay, So we have the 5 treatments, and 68.5 divided by 5 is 13.7. So you'll get the average. You can make all the average of this. Okay. So this is the final table at the end you will get for the thesis. And another very important over here, you can see the source of variation. We can see the what type of source, so we get the variation in our design. So in our research also we can call that, but for design I can consider over here. So first we will get in our data the variation from the treatments, so that we need to calculate the degrees of freedom. So the formula of treatment here is the t minus 1. You can consider any later, no problem. Then another rows t minus 1, column t minus 1. And very important, that is the error degrees of freedom. We consider that the 12, so that I consider 5 as to 5, and this is Latin square design is 5 to 8 treatments only. Okay, keep in mind that. And here you can see the t square, because we are squaring the treatment. We consider the 5 treatment and we squaring that treatment. Okay, so that here is the t square, or n means the total number of observation. So we have total number of observation. 5 into 5 is the 25. So 25 minus 1 is the 24. This is the total. For the treatment, we have the 5 treatments. 5 minus 1, 4. Rows 5, 5 minus 1, 4. Then columns 5, 5 minus 4. Okay. Another error t minus 1 and t minus 2. So 12. Then we need to calculate the sum of square. I'll show the formula for the treatments. Sum of square you can calculate for the rows and column. Then here is the sum of square. Okay, you just consider the sum of square over here. You see here, sum of square S12 to S16. You see here the S12 to S16. Okay, divided by how many observations you have? You have 1, 2, 3, 4, 5. We can count it. Okay, K12 to O12. You see here the K12 to O12. We are counting, we are counting. You can put the 1, 2, 3, 4, 5 number as well, without using this formula count, and in bracket you will get this and this like that. Okay, and minus D29. What is the D value? You know that it's a correction factor. Got it? So we calculate the sum of square. You can calculate sum of square for rows, column, and error. Okay, then mean sum of square. I'll show the formula. F23 divided by E23. It means F23 is F, and this is 23. Means sum of square for treatment divided by E23. That is degrees of freedom. It's very simple, mean sum of square. Okay, just you can take this value divided by this value. You will get this value. It's very simple. Then F calculated, you can consider this is the F calculated with the help of error mean sum of square and treatment sum of square. Okay, you will get F calculated. For F table, you can use 0.5. For 1%, you can use 0.1%. You can use this formula, and just you calculate the significance. You know the you need to use the E function for this. Whether this value is greater than or less than, then show the significance or non-significance. You will get from this formula. Okay, so you can do same things for the F table 1% and significance. Okay, let's see the correction factor. You need to calculate the correction factor with the help of this formula, sum of square, and you can use count or just a number, whatever number you want to divide it with the help of this. You can see here the total number of observation. It means divided by n. Okay, so that you can calculate this P17. It means this value. This is we call it the GT value, that is grand total value. Okay, you can directly do this from this also, or you can use this value from this table as well. Okay, I think so. It's sufficient. Then you calculate the CB value, then standard error, mean, difference, then table value. Then you need to calculate CD value. Okay, CD value you can use this formula. Okay, for the CD value, you can consider the mean, standard error, mean. Okay, and here is the table value, so that you can do this CD calculation with the help of this formula. So it's easy. Okay, and now at the end you'll get the final thesis table, and this is the final one. So this is for the treatment A to E treatment, that is our 5 treatments, and we have here the treatment mean that we call as treatment average. Just you can consider over here, you will get the standard error, mean, plus minus, and CD value at the 5%. If you want this in the graphical data representation format, because this is the data and we need to make in the graphic format, then I also added this graphic formats over here. And this Excel sheet is available for the sale purpose if you want this Excel, and this is the fully automatic sheet. Okay, just you need to change the red color values. Means if you consider here A, B, C, D, E, this is the fully automatic design. It will consider your A, B, C, D and also calculate the mean for A, B, C, D automatically, right? So if you want this type of design Excel sheet, it's a paid Excel sheet. If you want, then I'll put the my WhatsApp number in the description box, and definitely you can contact me. Then definitely I'll share this sheet with you, because it's a soft copy. If you want to make your own, already I explained everything in this video, so that you can try to make you by yourself and take the help of your notes and different examples which are available in the market, and just you compile in the Excel sheet. It will be helpful. Thank you so much for watching.